Alright, what we're going to do is take a look at how to graph a hyperbola. And if you took a cone, your upper and lower nap, and you sliced it so that you go through both upper and lower naps, you would have, it's almost like the shape of two parabolas. You would have what was called a hyperbola. Alright, if you think about, if you're looking, if you're wearing shaped skis or a snowboard, if you looked down at the skis or the snowboard, the edges would form the shape of a hyperbola. Alright, so when graphing hyperbolas, you have two options. You can either have a transverse axis that is horizontal, or a transverse axis which is vertical. The transverse axis is always the axis that goes through the center and touches the vertices. Alright, so on this one on the right, our transverse axis is going to go up and down. Alright, and if you look at the equations here in standard form, you might be saying, wow, that's very, very close to the equation of an ellipse. How is it different? We have minus signs, so we are subtracting the two values. With ellipses, we are always adding. Alright, and if your x value is positive and your y value is negative, my transverse axis is going to go horizontal. If my y value is positive and my x value is negative, my transverse axis is going to go vertical. Alright, and now when we graph these, we're going to have to know the distance from the center to each focus. Alright, if we were to draw a line from the center to the endpoint of this is called the conjugate axis. The conjugate axis is the one that goes perpendicular to your transverse axis. If we were to draw this line and a line from the center to a vertex, this hypotenuse is actually the same distance as the distance from the center to the foci. Alright, so if we have a right triangle here, if we know this distance and this distance, we can find the distance from the center to the foci as well. And keep in mind Pythagorean Theorem, a squared plus b squared equals c squared, or smaller distance squared plus smaller distance squared equals larger distance squared. Alright, so suppose we were to graph y minus 3 squared divided by 4 minus x plus 1 squared divided by 9 equals 1. Keep in mind this minus sign tells us it's going to be a hyperbola. What we're going to do first is find the center. And the center, make sure you always look in your x values for the x value of your center. I'm going to use -1, the opposite of this, or what makes it 0, and a +3, and go ahead and plot that. Alright. The next thing we want to do is find the distance from the center for the x values. So looking at your x values, we have 9 here. We want to take the square root of that. The square root of 9 is 3. That tells me the distance along the x values from the center is going to be 3. So count out 3 in each direction. Alright, and then for the y values, the square root of 4 is just 2. So I'm going to go up 2 and down 2. And what you want to do is draw a draw a dotted box connecting these points. This will help us find the asymptotes in which our hyperbola will run. Alright, if you connect these endpoints of this box, the corners, diagonally, you will see that you can kind of see the shape of the hyperbola coming to. Alright, the next thing we have to do though is decide, will my hyperbola go open up to the left and to the right, or will it open up from the top and the bottom? And if we look here, I see that my y values are the ones being squared, so I know that my transverse axis is going to be vertical. So then this is my transverse axis right here, and from there these 2 points are my vertices. Alright, to graph this, start at your vertice and just go out and ride along the dotted lines you just made that are your asymptotes. Right, and there is your hyperbola. If you wanted to find the slope of these asymptotes, these dotted lines we drew through the diagonals, just from your center, how far did I go up? My rise was 2. I ran over 3 to get to the corner, so my slope is 2/3. I also did that up 2 and to the left 3 as well, so it's plus or minus. Alright, and the last thing we have to do is find the ordered pairs for the foci. And remember, the hyperbola is going to wrap around the foci. So there's somewhere in this area. I'm not really sure where they are, but they're somewhere in there. Alright, so if you remember with the Pythagorean Theorem and the triangle we drew before, if you look inside of this rectangular box, if I connect from the center to a vertice, to a vertex, and I connect from the center to an endpoint on the conjugate axis, and I draw this triangle, right? This hypotenuse is the same distance or the same length as from the center to the focus in both directions. So if I was to draw that, the bottom part of this would be a distance of 3. The top part would be a distance of 2. Right? And if you use Pythagorean Theorem, we know that 2 squared plus 3 squared equals c squared. So that's 4 plus 9 equals c squared. So c is equal to the square root of 13. So now I know that the distance from the center to either focus is the square root of 13. So if we were to write that as an ordered pair, I know my center is at -1, 3. My x values aren't going to change for my foci. So I'm going to stay at -1. The y values are going to be 3, and then plus the square root of 13 to get the above, and minus the square root of 13 to get below. So 3 plus or minus the square root of 13, and we're done. Alright, let's graph another one in standard form. Well, once again, you see there's a minus sign, so I know it's going to be a hyperbola. Now, my x squared values are first, so I know my transverse axis is going to be horizontal. The center is going to be 0, and the opposite of this, which is 1. And the distance from the center for the x values, the square root of 1 is just 1. For the y values, the square root of 16 is 4. So I'm going to go out 1 to the right, and I'm going to go plus or minus 4. Alright, and draw a rectangular box around these points and draw the diagonals from each corner, and that'll set up the asymptotes for our hyperbola. Alright, so now that we've drawn these, we kind of have an idea what this is going to look like. I know that the transverse axis is horizontal. So that means that my hyperbola is going to connect at these vertices. Alright, so when you draw this, from the vertice, go up, and then right along the asymptote, and do the same thing in the opposite direction. And do that for both of them. And there's your shape of your hyperbola. The last thing to do is find the foci and the slope of the asymptotes. The slope of the asymptotes, from the center we went up 1, 2, 3, 4, and over 1. So it's plus or minus 4 over 1, rise over run. To find this foci, remember, not really sure where they are, but they're somewhere in this region. Right? So if you want to draw your triangles, a triangle is going to look something like this. Alright, it'll be something like that, and we know that this distance is 1. I know the height is 4. So what is c? Just take a squared plus b squared equals c squared. So that's 16 plus 1, which is 17, equals c squared. So c is equal to the square root of 17. So, now keep in mind, this is going on my x-axis. My foci are now at, I was at 0, I'm going to the left, the square root of 17. I'm also going to the right, the square root of 17. And my y values have stayed the same. My height hasn't changed. Alright, and we're done. Alright, lastly, suppose we wanted to graph x squared minus 4y squared minus 2x minus 16y minus 11 equals 0. We know this is a hyperbola because, well, first of all, my coefficients of my x squared terms are different. So that tells me it's either an ellipse or a hyperbola. Now, because I'm dealing with one negative, I have a -4 here, we know it's going to be a hyperbola. So what do we want to do here is group our x terms together, group our y terms together, and move our constant over to the right side. All right. Once we group the x terms and the y terms together, we want to complete the square for both of those. Since my leading coefficient of my x terms is a +1, I'm good to go there. Half of -2 is 1. 1 squared is 1. All right, remember I have to add this on the other side as well. For the y values, I can't have a leading coefficient of negative 4. So what I did is I factored it out. So now we have negative 4 times y squared plus 4y. Now keep in mind, if you were to distribute this back through, you'd get negative 4y squared minus 16y. And now we can complete this square. Half of 4 is 2, 2 squared is 4. And now keep in mind, I added a 4 here to complete this square, but when I distribute this back through, it actually turns out to be that it's a negative 16 I was adding to the left side, so I have to add that to the right side as well. And what we can do now is complete the square for both of these by factoring. Alright, so I completed both of these squares. The only problem now is when we graph hyperbolas, we always want it set equal to a positive 1. So we have to divide everything by a negative 4 to turn this into a positive 1. Alright, and when we do that, we get an x minus 1 squared divided by negative 4. And these reduce to a positive 1, so I'm at plus y plus 2 squared, that's over 1, equals 1. And now this isn't written in standard form. I have to take my left fraction and move it over to the right, so I have to switch these. So we get y plus 2 squared divided by 1 minus x minus 1 squared divided by 4 equals 1. Alright, and now we're good to graph. Alright, you can see that the center is going to be at 1, negative 2. The distance from the center for the x values, make sure you're looking at your x fraction. The square root of 4 is a 2. For the y values, the square root of a 1 is just 1. So I'm going to go out 2 in each direction for my x's and up 1 in each direction for my y's, and we're going to draw a rectangular box around those and draw diagonal asymptotes through the corners. Right. Once you've drawn those, now let's see, is our transverse axis horizontal or vertical? My y value is the positive value, so my transverse axis is going to go up and down just like the y values do. So it's going to be vertical. Alright, so my transverse axis is vertical, and what that means is when I draw my hyperbola, I'm going to connect with the vertices, which are on the endpoints of the transverse axis. And just draw these out, riding along your asymptotes that you drew through the corners. Right? And all we have left to do here is we can tell the slope of the asymptotes. I went up 1 over 2, so it's plus or minus 1 over 2. To find the foci, I'm not sure where they are exactly, but I know that they're being wrapped around by the hyperbolas, the lines we drew. Alright, so if we drew our little triangle, I have the distance from the center to one of the vertices and the center to the conjugate axis. That hypotenuse is going to be the distance from the center to each focus. Alright, so if I were to draw that triangle, I know that the bottom distance is 2, the other shorter distance is 1, and we'll make that a c. And using Pythagorean Theorem, we get 1 squared plus 2 squared equals c squared, so 5 is equal to c squared, so c is equal to the square root of 5. So the square root of 5 is the distance from the center to each one of those foci. To write that as an ordered pair, my x value isn't going to change. So that's going to stay at positive 1. And now I've gone up the square root of 5 and down the square root of 5 from negative 2. So negative 2 plus or minus the square root of 5. And you're done.